And today, what we are talking about is data architecture. So, an introduction to this data architecture document that we are drawing from, and the excerpts from it that outline the core concepts about activities and implementations and considerations that address the increasing importance of data as an asset in modern organizations. The core concepts and definitions are that architecture is defined as a broad sense of something that refers to the organization's arrangements of components to optimize function, to performance, cost, and aesthetics. It is not just the end result, but also the process of the building as well. So to quote, that architecture refers to the art and science of building things and the result of the building process and the buildings themselves. So it is defined in some ISO 42010-2007 that architecture is defined and as the fundamental organization of systems embodied in its components, their relationships to each other and the environments, and the principles governing its design and evolution. So data architecture as a discipline is a facet of information systems design that focuses on the organization, the management, and the use of data. It encompasses the artifacts of models, definitions, and data flows. It has activities that form of the forming of the data architecture and the deployment and fulfilling of data architecture's intentions. Behaviors, it has collaboration and the mindsets and the skills of various roles. Levels of architecture are in the different practices as various levels within an organization, enterprise, domain, and project, and areas of focus, infrastructure, application, and data. Enterprise architecture encompasses domain architecture, including business, data, application, and technology. Data architecture's purpose is to help the organization to represent data at different levels of abstraction, enabling the understanding and information decision-making. It is fundamental to data management. So data architecture artifacts are specifications that describe the existing state, define data requirements, guide the data integration, and control data assets. These are vital metadata and should be stored in an architecture artifact repository. Business drivers. So the business drivers are to bridge between strategy and execution. Data architecture acts as a bridge connecting business strategy and technology implementation. So the key responsibility of data architects is to evolve products and service the based services, evolving the products and services based on emerging technologies, to translate business needs into data requirements, to manage data and information delivery, facilitating alignment between business and IT, acting as agents of change, transformation, and agility. Value creation. Data architects create and maintain organizational knowledge about data and the systems it moves through. This knowledge allows our organizations to manage data as an asset and realize value through improved data usage, cost reduction, and risk mitigation. Primary outcomes are data storage and processing requirements, designs of structures and plans that meet the current and long-term data requirements of the enterprise. Value drivers achieving value for the organization by optimizing technical footprints, improving efficiencies, and increasing data usability. Data architect specification goals are to define the current state of the data in the organization and to provide a standard business vocabulary for data and its components, to align data architecture with enterprise strategy and business architecture, express strategic data requirements, and to outline level integrated designs. Integrate with the overall enterprise architecture roadmap. Essential concepts. Architecture domains data architecture relates within the context of other domains such as business, application, and technical architecture. Collaboration between these domains is crucial as they influence and constrain each other. Enterprise architecture frameworks. These provide methods for understanding architecture. Common frameworks are like ZACMAN, include data architecture as an architecture. ZACMAN include data architecture as an architectural domain. ZACMAN framework, a well-known enterprise architecture framework that is used as a 6x6 matrix and shows the different perspectives on architecture, recognizing that different audiences have different views. 2 dimensions, communication, interrogative columns. What, now, what, how, where, when, why. Reification, transformations, rows. Identification, definition, representation, specification, configuration, and instantiation, corresponding to planner, owner, designer, builder, implementer, and user. Cells. Each cell represents a unique type of design artifact resulting from the intersection of its row and column. Enterprise data architecture defines standards and designs for important organizational elements, including data collection, storage, integration, movement, and distribution. Components of EDA, Enterprise Data Model, EDM. A holistic implementation, independent view of data including entities, relationships, business rules, and critical attributes. Serves as a foundation for data projects. Data flow design. Define how data moves through various components like databases, applications, and networks, linking data to business processes, roles, locations, and technical components. Enterprise Data Model, EDM, deep dive. Stand-alone artifacts or composed of models. An EDM, Enterprise Data Model, can be created as a standalone artifact or understood as a collection of models that describe data entities, attributes, and relationships. Industry standards. Adopting an industry standard model can jumpstart the process, but enterprise-wide data models require significant investment to tailor them to specific organizational needs. Incremental approach. Most successful EDMs are built incrementally and iteratively using layers. Levels of an EDM: conceptual, overview of subject areas, views of entities and relationships for each subject area, detailed, partially attributed logical views of the same subject areas, logical and physical models specific to an application or project. Relationships between models, vertical. Models at each level map to those at other levels, creating lineage. Horizontal entities and relationships can exist in multiple models within the same level and can be linked across subject areas. So, subject area models, the conceptual enterprise data model is built up by the combination of subject area models, and these subject areas must be consistent. Subject area discriminators, subject area structures are usually formed with normalization rules for most effective data architecture work. Other principles for forming subject area structures include funding, governance structures, top-level processes, and business capabilities. So, number 6, data flow design deep dive. Data lineage documentation. Data flows document how data moves through business processes and systems. Data flow elements. Data flows illustrates where data originated, where it is stored, how it is used, and how it is transformed. Data lineage analysis helps explain the state of the data at any point in the flow. Data flow mappings. So data flows map relationships between data and applications within a business process. Data stores or databases, network segments, business roles, CRUD, locations where local update and delete, local differences occur. Levels of detail, data flows can be documented as subject areas, business entities, or attribute level. Systems can be represented by network segments, platforms, or individual servers. Representations, data flows can be depicted by two-dimensional matrices, or data flow diagrams. Matrices show data created and used, while diagrams illustrate data flow between systems. Activities. Complexity management. Data and enterprise architecture address complexities from two angles. Quality-oriented, focus on improving execution within business and IT development cycles, maintaining architectural quality and improving standards. Innovation-oriented, focus on transforming business and IT to leverage new technologies and opportunities and using level-edge technologies. This approach requires architects to engage with diverse roles within the organization. Establishing data architecture practice. Data architecture should be an integral part of enterprise architecture. Use a framework to articulate goals, drivers, and scope for data architecture and communication with stakeholders. Develop work streams that include strategy, acceptance, culture, organization, working methods, and results. Impact on projects and systems, system releases, enterprise or data architecture influences. Project data requirements require for reviews of project data design to ensure consistency. Determination of data lineage impacts, data replication control, enforcement of data architecture standards, guidance of data technology decisions, evaluate existing specs, identify existing system documentation, evaluate and update as necessary. Develop a roadmap, providing a plan for a 3 to 5 year development path to manage data dependencies and trade-offs. The roadmap should be integrated with overall enterprise architecture roadmap. And it should be operated in data dependencies should resolve the business capability dependencies in order that data is created. Managing enterprise requirements within projects ensures that data models and specifications are flexible to accommodate future needs. Architects should analyze projects' specifications for adherence to standards, inclusion in the overall EDA, generalizability, and new delivery architectures. Address data architecture early in project planning. Project activities: define scope, understand business requirements, design detailed specifications, implement implementation with the development methodologies, waterfall, including data architecture in activities in sequential phasing, incremental, create a comprehensive data design in early iterations, agile, include specifications for data models, capture, storage, and distribution. Strong collaboration between programmers and data architects is vital. Integration with enterprise architecture. EDA work is driven by projects, but enterprise-wide EDA needs to be proactive and integrate with project portfolio management and enterprise application development, and also integration planning. 8 tools. Data modeling tools necessary for managing the EDM at all levels, including lineage and relationship tracking. Asset management software. Inventory systems describes content, tracks relationships, and provides valuable metadata to inform data flows. Graphical design applications used to create architectural design diagrams, data flows, value chains, and other artifacts. Techniques. Lifecycle projections. Categorize architecture designs based on current use. Zachman, and also want to have a look at value chains. So, lifecycle projections categorize architecture designs based on current use, future deployment, retirement plans, and use policies. Diagramming clarity, use consistent visual conventions to avoid misinterpretations, including clear legends. Line direction, consistent line cross display, consistent object attribute linear. This is interesting, this part. Diagramming, including clear lineage, line direction, consistent line cross displays, consistent object attributes, and linear symmetry. Implementation guidelines. Key aspects of implementation: organizing data architectures, teams, and forums. Producing initial versions of artifacts, EDM, data flow, roadmaps. Establishing data architecture way. A data architecture way of working in development projects, raising organizational awareness of the value of data architecture. Incremental implementation. Begin in part of organization or data domain and grow wider after learning and maturing. Early projects often require larger portions of data architecture work. Business drivers influence the implementation strategy, whether it's an agile approach in a culture that values innovation or a more structured approach in a quality-driven culture. So traditional approach is to start with master data improvements, then expand to traditional data and use governance to ensure compliance. Significant risks: lack of management support, no proven record of accomplishment, apprehensive sponsors, counterproductive executive decisions, culture shock, inexperienced project leaders, dominance of one-dimensional view. 12. Organization and cultural changes. Culture's impact. Architectural adoption. Speed depends on the adaptability of the culture. Data architects must collaborate with creative thinkers who might embrace or resist changes. Ideal organizations, output-oriented, strategically aligned organizations are best positioned to adopt architectural practices as they prioritize based on common objectives. Factors of architectural adoption: cultural receptivity to architecture, recognition of data as a business asset, ability to adopt an enterprise perspective, ability to integrate architectural deliverables into project methodologies, acceptance of formal data governance, holistic view of the enterprise. Data architecture governance. Data architecture's role is to support the alignment and control of data and acts as a liaison with data governance. Governance alignment. Enterprise data architecture should be aligned with data governance organization. Data architecture and data steward should be assigned to subject areas or entities along with business insight aligned with process oversight. Activities: overseeing projects for compliance with architectural standards, managing designs, life cycles, and tools, setting rules, guidelines, and specifications for data usage, creating compliance artifacts. Metrics: performance metrics reflect architectural goals, compliance, implementation, trends, and business values, tracked annually as part of overall project customer satisfaction. Architecture standard compliance rate measures how closely projects follow standards and engage with architecture. Implementation trends tracks how enterprise architecture improves project implementation, reusage of artifacts, and project efficiency. Business value measurements track progress towards business objectives and benefits, business agility improvements, business quality measurements, business operation quality measurements, business environment improvements. 15. Works cited recommended. A list of books on data and enterprise architecture was provided. So in conclusion, this briefing document provides a thorough review of data architecture, covering its definition, business drivers, key concepts, activities, implementation, and governance. It underscores the critical role that data architecture plays in enabling organizations to effectively manage and leverage data as a strategic asset.